Hi, good morning, good afternoon, good evening. I know we have participants from all over the world, which is very exciting. Welcome back to our session number 2 of this HVAC Controls Fundamentals series. Today we have an awesome session for you guys. It's on communication protocols and open systems. So we really hope to just demystify a lot of the confusion about protocols and help you understand what it means to be an open system. A few housekeeping items before we get into it. This session is going to run about 30 minutes, and then Grant and myself will stay after for an additional 15 to 20 minutes to help answer as many outstanding questions as we can. On that note, please ask any questions you have on the questions tab. And then lastly, we get a lot of questions about if the presentation will be available. While a video recording will not be available, you can download the handout on the Handouts tab. And last but not least, for all the latest updates about Distech product announcements and news, please follow us on LinkedIn as well as on Instagram. And I'm Stephanie Shahowski. I'm the Distech Regional Sales Manager for Southern California. And with me, Grant.
Hey, how's it going? Yeah, so I'm the New York City Regional Sales Manager for Distech. Been working on this kind of stuff for quite some time and really think this is an exciting topic that we have to cover today. Hopefully we can give you a bit more clarity on why protocols are so important and why open systems are so important. The final housekeeping item that I want to cover real quick before we move on is for those that are looking to get the engineering credits associated with these presentations, it is necessary for you to have attended the prior session, Controls Basics, this session on communication protocols, and then also the upcoming session on MSTP versus IP. All three of them need to be attended for us to be able to get those credits for you. It was registered with the state of New York for those engineering credits. So with that, why don't we go ahead and jump into this presentation, and I'll kick it off with just giving an outline of what we're going to review through today. So we're going to start with talking about open standard protocols that are specific to the HVAC industry, and then move into the physical layers that they communicate over, talk a little bit about the Niagara Framework, open systems, and then finish it off with APIs. So a lot of good conversations for today. So for starters, let's talk about open standard protocols. So traditionally in the BAS industry, whenever they first developed DDC controls, every manufacturer ended up making their own coding and form of communication that allowed one controller to speak to the next within a building automation system. So whether you're talking about Trane or Siemens or Johnson or all these other manufacturers, everyone had their own form of communication that they had developed, and it wasn't recognizable from one manufacturer to the next. What this ended up doing was causing a few issues for building owners. If they weren't happy with service or they want to combine together multiple systems, because these controllers were not identifying things in a similar fashion. So a temperature sensor could be labeled as one thing within one system and completely different and unrecognizable in another system. They weren't able to communicate to each other. And so it really kind of limited building owners to stick with the same system that they first installed, because it was really hard to allow cross communication between multiple vendors. So with that, the open standard protocols started to become a thing, which meant that every vendor was going to have a protocol that they can all adhere to so that everyone's speaking the same language. It means no matter which product line manufacturer you're talking about, they're going to be able to communicate the same language from controller to controller. And that allows a lot more interoperability between product lines and really leaves a lot more options on the table for an owner as they start to build out their building automation system and make expansions, changes to their buildings. So here we have the 3 most common protocols to the controls industry. These are really specific in many ways to the HVAC industry. Other industries such as lighting industries, security cameras, a lot of them have their own versions of open standard protocols. But these ones are very specific towards controls and the HVAC industry. And so we want to highlight them today, starting with BACnet that we have up in the left corner there. That one's become the most prevalent in our industry today. Definitely you will see BACnet more often than any other protocol that I have listed here. But the other 2 are important to understand and be aware of. Modbus I see most commonly with systems, third-party systems. A lot of times I'll see Modbus as a form of communication that boiler manufacturers like to use. The final one we have shown here is LawnMark. So lawn is definitely a big form of communication, and you will see that quite a bit. I would say a lot of existing infrastructures are using lawn. But as you'll kind of see, BACnet has become the most prevalent at this point, and that's what we're going to tune into a little bit further today, so that you can better understand what's specific about a communication protocol, and we'll align it around the BACnet standard.
And we already got our first question in, and I think we'll just address it real quick. It's what's the difference between BACnet, MSTP, and Modbus? And that's actually a really good question, but Grant, if you go back to the previous slide,
Sure.
Basically the communication protocols, the way the messages are packaged, formatted, the language, so they're all, it's hard to describe exactly what the difference is, but these are, I would say the important takeaway here is these are probably the top 3 top industry standard open protocols within the building automation industry. So just again, the way the messages are packaged, the languages, it's like what's the difference between English and French, right? You could say, there's a lot of differences, but at the end of the day, these are the most common, open, prevalent, widely adopted protocols in our industry.
Yeah, absolutely. And I think something that's, I think these 4 bullet points that I have on this slide kind of help you understand what goes into a protocol. Having really a method of describing the data and services for how you're transmitting data from one controller to the next, the way that you label different things, those are where you'll start to see those differences. But ultimately, it is something that for both Modbus and BACnet, they are standardized such that if no matter what manufacturer is using that communication protocol, they are doing it the same way. So that's the takeaway that you need to get to there. So with that, let's talk a little bit about BACnet. It was founded in 1995 and supported by ASHRAE. I think it's being brought up through ASHRAE has really helped with its adoption into the HVAC industry pretty quickly. And it continues to be updated and maintained with that standard 135. They do have a means and methods for testing controllers with their BACnet testing laboratories. So what you'll find is that all manufacturers go through a process to get that BTL label put on their controllers. That shows that they do fully adhere to the BACnet standard, and BACnet approves of that. That is something you do want to look for with a product line. There are BACnet product lines that have not been tested by the BACnet laboratories, and they may have some subtle differences that they work with in terms of mainly the services that and how they transmit data from one controller to the next, other things that could potentially cause issues with them communicating to the truly approved BACnet product lines. So I think that's something to look out for, is having that BACnet testing laboratory symbol on your controllers. Look like you have something you wanted to add to that, Stephanie.
No, that was a great explanation. But yes, BACnet has been around as a standard since 1995. It's the most widely adopted standard out there. Would definitely encourage you, if you haven't been to the BACnet International website, you can learn a bunch just by clicking around for 15 minutes, looking at the FAQs. You'll notice different controller and device classifications, from BACnet building controller to application-specific controller and so forth. Also getting more into the fine print and nitty-gritty, you can also click on the various PICS statements, P-I-C-S, which actually shows kind of additional documentation of properties of the device, such as which properties are read-only data versus what you can actually write, meaning what you can command and control. But yeah, I just definitely encourage you to check out that website. You can learn a lot just by browsing it for a few minutes.
Yep, absolutely. So with that, let's go ahead and talk about the physical layers that they can communicate over. So BACnet, like I said, it's a language, but there's different physical layers that can be communicated over. What it started off as was being communicated over BACnet MSTP, which is a twisted shielded pair, usually 16 to 22 gauge wire. But it's really expanded into a lot of other physical layers that can be communicated over. I think as BAS systems have started to interact more and more with IT systems, you've seen a lot more IT traditional technology and layers of communication being used with being used to communicate the BACnet protocol. So I think want to just point out these other ones that are available as BACnet over IP, which that's a Cat6, Cat5 cable, Ethernet cable, same style wiring that you would be using to plug your computer into your wireless router for your, hardwired Ethernet connection to get your internet. So that same style cabling, it's very prevalent, easy to find in the industry, not just in the HVAC industry, but across the board with a lot of other industries as well. So we will further deep dive into a discussion of MSTP versus IP in a future session. So keep an eye out for that. Looking forward to talk more about that. Then the other two we have here are BACnet over wireless and BACnet over fiber. So these are two other ones to keep an eye out for. There are situations that will arise that you will definitely find these two as something that you either need or want to take a look at. So it's good to know that there are a lot of different ways that you can communicate this protocol. So now we're going to move into the Niagara Framework. So this is an interesting little topic that I like to bring up because it's something that's recognized across it's not just specific to any real manufacturer in terms of the product line, the services available, the software infrastructure. It's really expanded out to be accepted by any building automation systems manufacturer, but also even beyond that into it can end up being the building level or enterprise level control for lighting systems, for security camera systems. All these different systems can be brought back into this Niagara framework. It's really meant to be a universal software infrastructure to bring together data, aggregate it, and allow you to store it into one main system. So I like to compare it to Microsoft's to just give you a better understanding of how it really works. So just like how Microsoft has Windows 10 as an operating system, Niagara 4 is the current operating system for the Niagara Framework, and it works in a similar fashion as Windows does. It's not specific to hardware in many ways. So just like you can install Windows on a Dell, an HP, an Acer computer, all these different computers, it's not really limited to the type of hardware that you're putting it onto. Same with servers. That's the same as Niagara. So Niagara has what they call a JACE, a Java Application Control Engine. And these JACEs are not specific to any manufacturer. You can get a JACE with any controls manufacturer. And also in terms of the enterprise level of control, which is a server, you could use any type of server and bring in the Niagara supervisor as that enterprise level of control for a building. And the final piece that is important to look at is the drivers. So same as you can install a driver for a printer, a mouse, a keyboard, whatever onto your computer, you can do the same thing with Niagara. So it has a lot of drivers available, and that's really what makes it such a universal framework and infrastructure, is that it has all these drivers available. So not only drivers for BACnet and Modbus, but a lot of other systems like I've labeled here access communications. That's a form of communication for security cameras. So they built out this library of drivers to allow you to bring together a lot of different systems into one universal platform.
Mm-hmm. Yeah, great explanation. So just to help clarify, BACnet, LAN, Modbus, those are all protocols, and now we're shifting gears a bit to the overarching framework. So the Niagara Framework, it's really great at just bringing together all sorts of disparate protocols, so you can have a BACnet system with also some Modbus meters, you could have a trunk that's LANWorks, and, bringing all these different protocols together under the Niagara Framework. Another analogy I like to bring up, so I really like Grant's analogy about comparing Tritium and the Niagara Framework to Microsoft and Windows, because it's an example we can use every day and relate to. Another example I like to compare that to is the cell phone industry, right? So if we think of the Android operating system, it can work across a handful of different manufacturers' hardware devices, right? You got a Sony cell phone, Google, Samsung. I'm sure there's dozens of others I'm forgetting, but it's the same core common software across various manufacturers' devices, or hardware rather. So that's analogous to the Tritium framework, or the Niagara framework, which you can use different manufacturers' hardware, but at the heart of it, it's the same core common software. So it's kind of manufacturer and protocol agnostic, same core common framework. But conversely, so we talked about Android. Now, if we shift gears and gave an example of a proprietary system, we can think of maybe the iOS, the Apple operating system. It will only run on Apple hardware. So I'm sitting here, I got my iPhone 10 XR, iOS will only run on Apple hardware. So again, the open analogy would be the Android operating system.
Mm-hmm. Yeah. So having something that is pretty universal, can be picked up by any manufacturer and recognized, is important. And it's not just specific to the communication protocol is what we're kind of driving towards here. So as you can see with the Niagara Framework, these JACE building level controllers I mentioned, that Java Application Control Engine, it's not just specific to any one vendor. A lot of the BAS vendors have their own form of a JACE. nice fun different colors here, but they all operate the same way. They all still run that Niagara framework within them. So it's easy for one manufacturer to come in, look underneath, so to speak, underneath the hood of the controls engine and know what's going on pretty quickly if it's using Niagara 4, because it's not specific to any one manufacturer. It is important to make sure that it's open whenever you are using Niagara. Niagara does have ways to lock out the controller and software and tools available with it to a specific vendor. So you do need to be aware of that. You definitely don't want a vendor to lock down that controller line such that if you want to have two different manufacturers in the space, they wouldn't be able to work off of each other's Niagara controllers. And with that, I'd say I definitely recommend to do that. You just mainly specify that you need an open NIC statement, and the way you can do that is outlined in this little table that we have here. So NIC stands for Niagara Compatibility Statement, and there's settings within that that allow for communication no matter what manufacturer we're talking about, and allow for tools, for programming tools, etc., to work consistently across the board.
Yep, and I was just going to add, in the majority of specifications, I am seeing this table just either copied and pasted in specifications. And again, this table really does ensure that this Jace building controller will be unlocked and open. The Distech Jace, the EC Boss in the upper left-hand corner, it always comes unlocked and open. But otherwise, just with all if you're not sure what manufacturer you're going to get, it's really important to add this table to ensure it is unlocked and open. Conversely, if you're an owner or an engineer and you're at the customer's site or at your own site, on your Niagara station, you can right-click on Properties, and it would have an asterisk to where it says Station Compatibility, in, out, Tool Compatibility. So that's the way you could kind of double check on your own system, is it would show an asterisk, which means it's open and not locked.
Cool. Yeah. So we're really just trying to drive towards different ways that you can make sure you have an open system, give owners the ultimate means of choice, no matter how they end up expanding and changing their building over time. So some things that I think are also very important. Niagara is part of the equation towards making an open system, or could be part of. But here are some really big ones that I think, if we're going to focus on making an open system, you really want to make sure you have. For starters, you want to have an open standard communication protocol. So that could be BACnet, be Modbus. We also talked about LAN, RESTful APIs, which we're going to talk about a little bit further at the end, are all open standard protocol communication protocols that are recognized across various manufacturers. That ensures a nice open system. Some other things to really consider. I think that having free programming tools is a huge differentiator in having an open system. So that allows anyone to go on site, have a freely downloadable programming tool to be able to make changes as needed to a system, or if they need to combine together two different systems, they have the tools available to do that. They're not having to go back to the previous manufacturer asking for those tools just so that they can make a few changes or combine together systems. The final thing is having multiple local product installers. I find is a good way to have choice for owners. So that allows owners, if they do get caught in a situation where they're not fully happy with the service they're getting, there could be another local installer there that knows how to work with that product and can continue to maintain their system for them. So all these are great ways to ensure that choice and openness for owners in their buildings.
Mhm. Yeah, you could. I mean, you could easily argue technical details all day long about what's considered open. I'm sure we could have a great debate, but at the end of the day, you want to, make sure the owner has choice in terms of ownership of their system, meaning the tools, choice in terms of how they want to expand on it, and so forth.
Yep. So now we're going to talk about APIs, because this is another open way to communicate, and it's not really just specific to the HVAC industry. It's really expanded. It started in the IT world back in the early 2000s as a way to allow different web services to communicate with one another in a nice encrypted and authenticated fashion. So it is a very secure way to have disparate systems communicating amongst each other. And it's expanded out significantly with the advent of all these different IoT, Internet of Things technologies out there, such that it's really been adopted across the board with a lot of different platforms and services so that they can communicate between smart devices and platforms in a very simplified way that developers can easily access code and read and write to it. Or in the API world, it's get and post is what they call it, to allow them to communicate between these systems. So I guess I went off on a little bit of a tangent there. I should have started by saying API does stand for Application Programming Interface. For those that were questioning that part of it, sorry about that. But let me go ahead and drive into some examples here of how APIs can be used to make this a little bit more relatable for you. So one example we have shown off on the left is just a Amazon Alexa communicating with some smart light bulbs and being able to turn them on and off, change the colors, etc. So Amazon didn't make those light bulbs that are shown there, but because they have a documented, easy to access set of APIs, that allowed those two to actually communicate with one another in a meaningful way. So you can tell your Alexa to change the color of those light bulbs, turn them on and off, even though they are different disparate systems, not by the same manufacturer. APIs enabled that communication. Same thing as we could compare to is Google Maps. Google Maps is definitely one of the most broadly recognized mapping systems. So for many people, it's not worth reinventing the wheel. It's better off to build on top of that wheel whatever you'd like to be doing. So Uber was a great example of that. They were able to build a rideshare platform over top of the Google Maps system. So they leveraged Google Maps API and put their rideshare system over top of that. So those are two interesting examples of how that can be used. But in the BAS industry, we, along with communicating to smart devices, applications, I think you need to be thinking about how many things are starting to move to the cloud. A lot of data is starting to get stored in the cloud. That's becoming a big thing in the BAS industry. And you want to be able to open up all these different analytics platforms and apps and services, and APIs is a way of doing that. So final thing, I just want to kind of show here how these really work, and at a 30,000 foot level. What APIs are is they're just really well documented scripts of coding that are available so that developers don't have to really reinvent the wheel. They can utilize the coding that they're used to working with, such as Java, XML, etc., and go to different websites. Like Google Maps has a developer's website that teaches you pretty easily how to take a few snippets of their code and leverage their mapping system through that API. DizTech does a similar thing with our Eclipse product line. We have a very well-documented website that a developer would be able to go there and learn how to read and write to our controllers. Anything you want to add in on API stuff?
No, I think you did a great job. But I remember I was impressed when I first heard of APIs a few years ago, and one of our colleagues was able to just, at a side project at home, he was able to write an API from his Amazon Alexa to one of our BACnet IP controllers, and was able to tell her, or ask her rather, to adjust the temp, ask her what the temperature is, do things like that. So someone with very little kind of IT programming experience was able to write an API just looking at the documentation. So it is becoming, some might guess, yeah, we might be using APIs more in the future, and especially as building management systems are increasing their functionality, and we're doing more with like the Internet of Things and more connected devices. APIs are a way to really communicate to anything and everything, because some of these miscellaneous devices or things we're trying to connect to, they might not speak a building automation specific protocol like BACnet or Modbus. Alexa doesn't speak BACnet. She's not a building automation device, but she's able to speak. We're able to find the common language being an API, and that's really, I think we're going to see a lot more of it in the future. Next week's session on Tuesday, we're going to get more comparing BACnet MSTP versus BACnet IP. And it's not just the actual communication protocol that's different, but many manufacturers, their IP controllers just have a lot more horsepower, processing speed, as well as these native API capabilities. So you're not just changing the communication cable, it's a dramatically different controller, which allows you to do more, which we'll get into more next Tuesday.
Cool. Yeah. So with that, looks like we're up on time. I really want to thank everybody for joining in. We are going to stick around, answer questions. For those that have to go, we look forward to seeing you next Tuesday. But let's go ahead and jump into some of these questions and see if we can run through those.
Yeah, and I was trying to answer some as we went, but maybe it would be good to clarify some of these questions I answered on the chat. And here's just a question kind of demystifying, can BACnet, Modbus, LAN all communicate with and between each other?
So what you would need is something in between is what we label as a gateway device. And that transitions the language from one to the next. That's the same as your translator on your phone or whatever you have there, allowing you to translate one language to the other. The hardware that we described, the Niagara Jace, is an example of something that could be a gateway, and that's allowing different languages to be sent to it, and then it's able to aggregate that data and transition it all to, let's say, BACnet protocol, so you can read it all in BACnet.
Yep. So you can think of that gateway as a United Nations translator, being able to translate German, English, Japanese, whatever, into a common protocol that allows, devices to all communicate and work harmoniously. All right. There's a question about just Niagara and Jace, like where can you find that property table in the Jace? And I just said, if this was coming from if this question was from a consulting engineer, I encourage this to be just the NIC statement to be asked for at the submittal time. if it's not already in the manufacturer's data sheet. But that's definitely something you have the power to ask for to make sure the owner is getting an open system.
Yeah, if you can quite literally put this table, I've seen it a lot in the specifications to ensure that the manufacturers do provide that and adhere to it.
Yep. Here's a good question. Does using Niagara increase the cost of the control system?
I don't really see how it would. I think Niagara is just another means of a front end for a communication system, but in its case, it's more universal across more manufacturers. There's nothing that really differentiates it in terms of cost wise, I would say.
Yeah, you're gonna, I mean, within the last session we described what components make up a building automation system, from specialist labor, electrical install, controller, hardware and software, and you're gonna need some type of software. So whether it's a proprietary version or an open Niagara version, they're priced very similarly, and usually they're scalable based on number of points or number of devices. So, you're gonna pay less for a smaller system, probably more for, a larger, robust system with hundreds of thousands of points.
Yep.
All right, here's a great question. Is there a library of APIs that have been created to allow future projects to benefit from work done on past projects?
Yeah, so I would say there's some to it where you're going to have well documented things that are out there, but occasionally you will see situations where developers come up with something that is really out of the box, not something that's very common to the industry, and they'll kind of keep that in-house to whoever they made that for. Distech is definitely, from our standpoint, we're trying to quickly develop things to make sure we have a lot of functionality available out of the box. But anything that isn't there, try to, there's probably a developer that you could find to do things that are different, right? I think that's one of the cool parts about APIs is that it's just like whenever you first download whenever you first get your iPhone, like you're allowed to start downloading all these different apps that are made by all these different developers. It allows a lot of different people that are not traditionally playing in the BAS industry to develop things that may not have been thought of directly by a controls manufacturer.
Here's a great question. If I unplug one manufacturer's back to MSTP device, can I simply plug in another manufacturer's back to an MSTP device?
So that's a great question. And it can get a little bit tricky at time with BACnet MSTP. So what you'll find is that different manufacturers occasionally use different transceivers on their controllers, and a lot of times some of them will use different gauged wire as well that works best with their specific controller line. And like I said, that range can be anywhere from, I've seen 16 to 22 gauge wire being used for BACnet MSTP communication, that twisted shielded pair. And the other thing is they can communicate at different baud rates. So one controller may slow down the communication of the rest of the chain, depending upon which, the differences amongst manufacturers. Usually best practice is to keep like controllers on one link and unlike controllers on a separate link. But you can always test out and talk with the controls manufacturer beforehand to ensure that you're not going to run into any issues with that.
Mm-hmm. All right, here's a great question. What is the meaning of a station and tool, and how do they differ?
Station and a tool and how they differ. Okay, so the tool is really just talking about a programming tool for your control system. So it's saying, that tool, if I have a Niagara programming tool for DizTech, and then someone else has a Niagara programming tool for, let's say, Honeywell, that tool has compatibility whether I'm plugging into anyone else's Jace. And where station comes down to is that's talking about allowing these different manufacturers to communicate from one to the other, I would say. Does that cover that pretty accurately, Steph?
I think so. Yeah. I know we get technical very fast. Let's see. If a product doesn't have an open NICS, how can you make it open? And typically I've seen this where the end user can write a letter to Tritium or to maybe the manufacturer, the Niagara manufacturer they want to use, and it can typically be opened up. Sometimes it might cost a little bit of money, but typically if it's fairly recent, you should be able to open it up. But that's why we like to go out there and do these lunch and learns with consulting engineers to nip it in the bud and make sure they get an open Jace, from the get-go. But you should be able to open it up.
Yeah, it usually involves a letter from a manufacturer. Occasionally, they do have charges associated with opening up a system. I have seen that once or twice before. So best case scenario is that you specify it all open and confirm that it is right from the beginning so that there aren't any issues with that on the back end.
Mm-hmm. All right, we have a great question. I think we might touch on this on a later session, but can we help explain BACnet SC?
Yeah, so BACnet SC, we are definitely going to touch on that. I think in our 5th session is what I'm going to compare BACnet SC to APIs. But just for high level, BACnet SC stands for Secure Connect. And it has been developed, it's been developed by ASHRAE, mainly around the fact that the BAS and controls industries had a lot more interaction with the IT side of things than what was originally intended whenever they first developed the system. A lot of times, like whenever BACnet was first used back in 1995, it was a kind of standalone system, wasn't interacting with anything on the IT side, maybe usually wasn't even connected to the internet at all. But now that you're seeing it connected to the internet, maybe working on the same backbone as the rest of the IT infrastructure, the IT industry started to give some advice towards how the protocol could be improved in terms of security measures. These IT is definitely, they are the masters in that. They're always constantly trying to limit the amount of hacks and make sure that they have the most robust, secure system. So they gave some advice towards that, such that with BACnet SC, it's supposed to have a lot more secure of a system and allow it to interact with IT systems in a better way and open up towards things like cloud services in an easier fashion than what's traditionally seen.
Mm-hmm. Yeah, just to add on to what you said, I mean, BACnet, the protocol came out in 1995. I think that was when I was still, collecting those CDs at the checkout aisle of the grocery store, right, to get a free 30-day trial of dial-up AOL. So we've come a long way with internet security and just like the capabilities of the hardware. I guess along with that, BACnet, it's a living standard. So just because something was tested and had that BTL stamp in like 1999 doesn't mean it meets today's standard. So BACnet's a living standard, continuously improving, and for just today's security that we need. it's going to be probably widely adopted in the near future here. So stay tuned for a later session, and we'll go deeper onto BACnet SC, which stands for BACnet Secure Connect.
Yep. I think that pretty much covers most of the questions that we had here. Really want to thank everybody for sticking around for the questions and for joining in. We look forward to capturing you guys next Tuesday on the MSTP versus IP discussion. So stay tuned. We'll see you next time. And
thank you guys. And if you do want to schedule a lunch and learn for your consulting engineering team, you can go to our website, distech-controls.com/resources. You'll see it at the top. Click on consulting engineers, and you guys can sign up for your own dedicated lunch and learn with your Distech regional sales manager. Or one of us. If you're lucky, it might be one of us if you're in Southern California or New York City.
Yep, absolutely.
Yeah. All right. Well, thank you guys so much. Look forward to seeing all of you on Tuesday. Tell your friends. We can have up to 3,000 attendees on here. So tell your friends, tell your enemies. Let's get everybody on here.
Thanks.
Have a great week. See you guys. Bye.